Hi everyone, welcome to chapter 6, Chemical Equilibrium. So we will look into detail 6.1 Dynamic Equilibrium, 6.2 Equilibrium Constant and 6.3 Le Chatelier's Principle. For this topic, we will look into detail 6.1 Dynamic Equilibrium. So untuk 6.1 tak banyak pun, it's just you need to learn the new concept, ada beberapa new concept. At the end of the lesson, you should be able to explain the reversible reaction, dynamic equilibrium and law of the mass action, and state the characteristic when the system is in equilibrium, and explain the changes of concentration of reactant and product when you have the graph of concentration against time for a reversible reaction. Okay, you have irreversible reaction and reversible reaction. So we will look into detail after this. Now let's focus on irreversible reaction. So most of the chemical reaction that you know, it will proceed until it completes. Means the reaction will continue until one of the reactant is finished, completely used up, and then the reaction will stop. Means the reaction akan take place in one direction, satu arah sahaja, ataupun in another words means you have reactant and then the reactant will be consumed, habis, and the reaction will stop and you will get your final product. So contohnya you have CH4 react with Cl2 and both of them are the reactants, and you will form products CH3Cl plus HCl. So in this case, this reaction is one direction and it cannot be reversed. Maksudnya produk tak boleh jadi reactant semula. And another example is you have HCl plus base now. So kamu akan dapat NaCl plus water. So this is also an example of irreversible reaction. So reaction tu hanya berlaku dalam satu arah saja daripada reactant, habis dan akan menghasilkan produk. So ini adalah konsep that you have learned before this. Dia akan ada konsep limiting reactant. Okay, tapi untuk this chapter 6, kita tak fokus on this limiting reactant. Kita akan fokus for reversible reaction. Okay, so apa tu reversible reaction? Okay, it is when the reaction take place in both way. Maksudnya daripada reactant menghasilkan produk and produk boleh menghasilkan reactant ataupun decompose ataupun terurai untuk menghasilkan reactant semula. Okay, so you can see here, not all of the reactants are changed to product because product can dissociate back to form the reactant. So means this reaction will take place in both direction. So arrow yang kita akan pakai adalah arrow reversible. Okay, so you can only use this arrow, bukan begini. This is for resonance and not this way. Ni pun salah. Only this type of arrow yang dibenarkan. Okay, so you can see here, if you have reactant A and reactant A akan menghasilkan produk B. So tak kisahlah reactant kamu hanya satu, 2 or more. Okay, so as long as you can identify and separatekan the left hand side adalah reactant and the right hand side, okay, bahagian kanan adalah product. Okay, so if the reaction proceed from left to right, we call it as forward reaction. Okay, so means this is the forward reaction from A menghasilkan B. And then let's have a look if you have from right to left. Maksudnya produk menghasilkan reactant kembali. So this is called as reverse reaction. Okay, forward. Ini adalah forward. And this is your reverse reaction. So, chemical reaction that take place in both forward and reverse direction, we call it as reversible reaction. Okay, so ini yang kita akan fokus dalam chapter 6. And only indicate the reversible reaction with this kind of arrow yang berpatah balik ni. Okay, so let's say you have hydrogen gas react with iodine gas. Okay, so you have hydrogen react with iodine, you will get the product as hydrogen iodide. Okay, so ini adalah if from left to right, it is a forward reaction. Okay, tapi this is a reversible reaction. So maksudnya hydrogen iodide kamu boleh form. This is the reverse way. So means hydrogen iodide akan terurai kembali menjadi hydrogen gas dan iodine gas. Okay, so in a reversible reaction, initially the reaction proceed to form hydrogen iodide as I explained before. As soon as some of the product molecule form, and then bila dah terhasil beberapa hydrogen iodide, barulah boleh berlaku reverse process. So maksudnya hydrogen iodide ni akan slowly dia akan hasilkan semula iodine gas dan hydrogen gas. So reactant hydrogen and iodine will be formed from the dissociation of the product which is hydrogen iodide lah di sini your product. Dua ini adalah your reactant. So let's have a look at concentration against time punya graph. So for this graph, you can see one axis is time and it's against the concentration at another axis. Okay. So from the graph you can see, so ini adalah your equation. Your equation is reactant, A adalah reactant and B adalah kamu punya product. Okay, so when you have this reaction, reactant A at the beginning, ini adalah starting of your reaction. So concentration A at this point, okay, adalah sangat-sangat tinggi, yang paling tinggi lah, because you have your, so let's say at the beginning of the reaction, concentration of A is very high. So as time increase, so time bertambah, contoh 10 saat, 20 saat, 30 saat and so on. As time increase, the concentration will slowly decrease. Okay, so you can see concentration of A decrease with time. Okay, so kita fokus until dotted line merah ni dulu. Okay, so you can see here, concentration of species A akan berkurang until it reach this point. Okay, so for concentration of B pula, okay, B adalah kamu punya produk. So, at the beginning of the reaction, produk tu belum lagi terhasil. Okay, in this case, you have zero amount of the product. So, when A dissociate untuk hasilkan produk B, so makin lama makin increase time, 10 saat, 20 saat, 30 saat and so on, you will have the increase in this graph. Concentration of B akan slowly increase until it reach this point. Okay, so you can see at certain point ataupun at certain time, you can see here concentration of A and B akan remain constant. So you can see here, dia akan menjadi mendatar begini. Okay, so concentration of A pun after this point dia akan jadi constant. Dia bukan sama, it is not same. Okay, dia tak sama. You can see ini ada value lain. And then here dia ada value lain. So contoh concentration sini adalah 1 molar, sini adalah 5 molar. Okay, value-nya berbeza. Constant means dia akan jadi mendatar. Okay, so you need to take note that as reaction proceed, the rate of the forward reaction will decrease and the rate of the reverse reaction will increase. Okay, so bila at this part, rate of the forward akan berkurang and rate of the reverse reaction akan meninggi, semakin meningkat. Okay, but when the rate is equal to one another, okay, so when the rate of forward and reverse is equal, concentration of A dan B akan jadi constant. So means at this point, rate of reaction untuk both forward dan reverse reaction, okay, both adalah sama, therefore your concentration dia akan jadi constant. Okay, maksudnya A akan continually convert jadi B, reactant akan continually convert jadi product, and B, your product akan continually jadi converted back to form the reactant A. Okay, so at this point, the system we set as equilibrium. Okay, means the system is in chemical equilibrium. After temperature, certain temperature, contoh at T1 here, at specific time here, the reaction will still continue indefinitely, maksudnya tanpa had lah, dia akan continue and equilibrium as achieved. So this is what we call as dynamic equilibrium. So for equilibrium, apa itu equilibrium? It is a state where there are no observable changes as time increase. So you can see graph tadi, bila time bertambah, when you increase the time, okay, you can see the concentration dia akan jadi constant. Begini. Okay, so concentration of your reactant and product jadi constant. So there are two types of equilibrium. First is physical, and then the second one is chemical equilibrium. So what are those? So first, let's look at physical equilibrium. So physical equilibrium, as the name said here, it is physical. So it involve physical changes. So maksudnya dia adalah changes of state. State dia berubah. Means daripada contohnya liquid pergi gas. Okay, so ini berpatah balik lah, reversible. Ataupun solid to liquid and so on lah. Yang melibatkan physical. Yang kamu boleh measure the physical changes. Okay, so for example, you have evaporation of water and it must be in closed system. Okay, so remember equilibrium ni. One more thing about equilibrium that you need to know, it only happen at closed system. Okay, so maksudnya tak ada yang kalau in open system, contoh evaporation, dia akan ada evaporation into the air and loss of your compound tu. Tapi in equilibrium, kita assume that kita conduct the experiment in a closed system. So your reaction will happen in this closed system lah. Okay, so let's see the equation. H2O in liquid, it can be converted into H2O as vapor or vice versa lah. So ini adalah your forward reaction. Forward liquid convert to vapor ataupun gas, and from gas it can be reverse. Dia akan form balik liquid. So this is called as physical changes, and the system is in equilibrium when number of H2O molecule leaving is equal to the number of H2O molecule returning as to form liquid semula. So let's consider this reaction for chemical equilibrium. Okay, so for chemical equilibrium means you have changes in the reaction chemically. Okay, so you have, let's say you have dinitrogen tetraoxide here, N2O4, and then it will form product. So ini adalah your reactant and your product. So your product is NO2, nitrogen dioxide. So N2O4 ni dalam keadaan colourless and your product is in brown colour. So at the beginning of your reaction, okay, so kalau kamu buat graph, so concentration against time, okay, as time increase, concentration of N2O4 tu dia akan berkurang. And then this is reactant lah, concentration of N2O4. And as time increase juga, you will produce the product NO2. And then at certain time, kamu akan dapat constant concentration. Means there's no increase in the concentration anymore. And this is the product NO2. Okay. So level lah dekat mana dia start menjadi constant as time. Time yang tertentu itulah. Okay. So the explanation here, when we introduce N2O4 into the seal flask and kept at 100 degrees Celsius, a change occurs immediately. Okay, so daripada colourless, dia akan slowly turns into brown. Okay, so the liquid vaporize and the gas begins to turn pale brown. Mula-mula dia jadi chocolate powder, pale brown, and slowly as you increase, slowly as you increase the formation ataupun concentration of your NO2. NO2 ni kan dalam color brown. Okay, so your flask tu dia akan slowly getting darker, darker and darker lah, penuh dengan brown from the NO2 gas. Okay, and until there's no further color change seen, means the rate of forward reaction is equal to the rate of reverse reaction, means dia dah capai equilibrium. Okay, so in a reversible reaction, both forward and reverse reaction will continue indefinitely. Okay, so maksudnya dia akan terus berlaku walaupun equilibrium dah established. Okay, it's already in equilibrium. Therefore, this chemical equilibrium, we call it as dynamic process ataupun dynamic equilibrium. The reactant and product concentration stop changing. Maksudnya dia akan jadi constant sahaja because of the forward and reverse rate have become equal. Dia dah jadi sama. Equal. Rate of forward reaction is equal to the rate of reverse reaction. So this is when it is in equilibrium. Okay, so maksudnya equilibrium tu it come from the word equal lah. In equilibrium means the rate of forward is equal to the rate of reverse reaction. So take note that equilibrium can only occur in closed system, as I mentioned before, hanya berlaku dalam closed system. It cannot happen in open system. So, characteristic of a system in equilibrium, the concentration of both reactant dan product must be constant over time. Okay, dia mendata je kalau kamu tengok graph, and the forward reaction rate is equal to the reverse rate, and the reaction quotient, which we represent with symbol Q here, is equal to the equilibrium constant K. So for now, kamu just take note ini, the factor nombor 3 ni, and we will see this in 6.2 later. Next, let's proceed with law of chemical equilibrium. It is also known as law of mass action. It explains the relationship between concentration of the reactant and products present in at equilibrium in any of the reaction. So means at a given temperature, a chemical system reach a state which in particular ratio, okay, dia ada ratio of reactant and product concentration, and it has constant value. So kita tengok apa yang dimaksudkan ni, means okay, let's say you have this reaction. Okay, so reactant A dan B ni adalah reactant. So these two in pink ni adalah reactant. So C dan D pula adalah your product. Okay, so reactant A akan react with reactant B to form product C dan D. Okay, so the small letter here in purple color, it indicate the stoichiometric coefficient. Okay, so maksudnya the ratio lah untuk reactant A, contoh 1, 2 or and so on lah. It can be any value. So any of the ratio ataupun stoichiometric coefficient. So means when your equation the reaction achieve ataupun at equilibrium, okay, so you can represent ataupun according to the law of mass action, concentration of, apa yang kamu perlu tahu, when you write this, K equal to concentration of product divided by concentration of reactant. Okay, and to the power of its stoichiometry lah, contoh A, ini B. Okay, but in this case you can see at equilibrium, so K equals to, so ini capital K equals to concentration of product, ada apa sini, you have C to the power of its stoichiometric coefficient times with product D with its coefficient divided by reactant A and reactant B. Okay, to the power of its stoichiometric coefficient B. Okay, depends on the value lah dekat depan ni, on your balanced chemical equation. Okay, so take note that K here adalah your equilibrium constant. Okay, so kita akan banyak deal with this K. And concentration, kamu mesti tulis dalam square bracket. So ini adalah square bracket. So in chemistry, kamu tak boleh suka-suka hati guna square bracket ni, sebab square bracket maksudnya dia adalah untuk represent concentration. So maksudnya if you write like this, concentration of C ataupun concentration of HCl, contoh. Okay, it cannot be like this, concentration of HCl, begitu. Ini salah lah how you write the representation of apa yang kamu nak bagi tahu, concentration of the species. Okay, so bila kita nak cari value of K, equilibrium constant, so for K, it is equal to concentration of product to power of its stoichiometric coefficient divided by the concentration of reactant and its stoichiometry lah. Okay, so kalau ada dua produk, tulislah dua produk hasil darab. And if you have two reactant, then hasil darab of the two reactant. If you have 3, then 3 lah. Kalau ada satu je lah. Leave it like that. And one more thing, since we are dealing with concentration, okay, so untuk cari the equilibrium constant K, in this case, kita deal dengan concentration. So untuk concentration, let's say your equation ni mesti tulis phase. Phase means solid, liquid and gas. Okay, so untuk concentration, tak ada yang melibatkan solid. So if you punya equation ada solid, just ignore that. Okay, and just tulis dalam this equation hanyalah yang melibatkan liquid dan gas. Okay, so nanti kita akan buat extra example ataupun exercise dalam 6.2 nanti later. Okay, so now kita just belajar macam mana nak tulis dulu. So K is equal to concentration of product, in this case CH3COOH to the power of its coefficient ni 1. So depan ni semua coefficient 1. Make sure balance the equation. So when you write the equation, make sure it is balanced. And then check dia punya stoichiometry. Okay. And then tengok dia punya state of matter tu lah. So tengoklah solid, liquid or gas. Okay. So if you have two here product and these two adalah reactant. So both of the product adalah in liquid, so we can measure the concentration. Okay, and then divided by concentration of the reactant. Okay, so remember when you are writing the concentrations, so contoh concentration of CH3COOH. So mesti buat dalam square bracket like this. And next example, so ini it's already balanced the equation, and then gas, gas and gas. So means all of them can be written in representation of concentration. Okay, so K, to find K is equal to concentration of product over reactant to the power of its coefficient. Okay, so in this case you have ini satu saja product and you have two reactant. So it is concentration of SO3 to the power of 2. So tulis dekat sini. Okay, apa skrip yang kecil di atas. Alright, so divided by concentration of SO2 to the power of 2, and then concentration of O2 to the power of 1. Okay, so macam mana kita nak apply all these thing yang kita dah belajar. We will look into detail in 6.2. So make sure you know how to write this K. And K ini sangat penting lah konsepnya dalam chapter 6. Equilibrium constant ni sangat penting. Nanti kamu akan jumpa KC, KP and so on lah.